The next type of sequence we're going to focus on is what's called a geometric sequence. Now remember, we said for an arithmetic sequence, that's when you notice that the pattern is you're adding the same number each time. Well, a geometric sequence is if you notice that the pattern is that you're multiplying by the same thing each time. And that's what we're going to focus on today. Now we have a name for that. Just like we had D, the common difference for arithmetic sequences, we have R, the common ratio for geometric sequences. And that's just the number that you're multiplying by each time. So here's an example of a sequence: 4, -8, 16, -32, 64, ... So I'm looking for a pattern, and I notice the pattern is I'm multiplying by 2 each time. I start with a 4, and then I multiply by, it's actually -2. Start with a 4, multiply by -2, I get -8, times 2 gives me +16, times -2 gives me -30. So each time I'm multiplying by -2. That's why the numbers switch back and forth, positive, negative, positive, negative. So what I notice is it's geometric because I'm multiplying by -2 each time. And that number is the common ratio. So R is -2 for this example. All right, now I want to mention one other thing. One of the things we saw very early in the year, we said, just like in the last day of notes, we said adding and subtracting can be kind of the same thing. So can multiplying and dividing. So I want you to remember that dividing can always be thought of as multiplying by a fraction. So if I give you guys this sequence right here, 189, then 63, then 21, then 7, then ... you might notice to yourself that the pattern is I'm dividing by 3 each time. I started with 189, and each time I'm dividing by 3. But dividing by 3 can also be thought of as multiplying by 1/3. Dividing is multiplying by reciprocals. So if you notice that the pattern is that you're dividing by the same number each time, that's still geometric, but R is going to be a fraction. So if I'm dividing by 3, I don't say that R is 3. That would mean I'm multiplying by 3. So if I'm dividing by 3, it's still geometric, but the common ratio is 1/3. All right, so now let's take a look at formulas again, just like we did in the last day of notes. And we have a very common formula again that we're going to use. So we have AN equals A1 times R to the n minus 1 power. Now all we need to know is R, the common ratio, and A1 again, just like yesterday, just like the last day of notes. So as long as you know R, what we're multiplying by each time, and the first term, which you can usually see just by looking at it, we got our formula again. So let's do a real similar example to what we did in the last day of notes. Let's take our sequence from earlier and let's write a formula for AN for that sequence. So the important things that we noticed earlier are, number 1, this is a geometric sequence, and number 2, the common ratio R was -2. That's the number we're multiplying to get from term to term. Now the other thing we need, just like yesterday, we need to know what A1 is, but remember A1 is just the first term. It's going to be right there for you. So in this one, A1 is 4. Now the formula I gave you guys on the last slide was AN equals A1 times, and then in parentheses we have R to the n minus 1 power. So this time, this is actually even easier than yesterday. Yesterday we had to put D and A1 in and then multiply distributive property combined like terms. There's no extra work on this one. If you put the numbers in, you're done. So A1 is 4, R is -2, the exponent is n minus 1, and that's actually the answer to the question. You couldn't do any more work even if you wanted to. So don't try to multiply those two numbers. Like a lot of people will say, oh, well, 4 times -2 is -8. And they'll put their answer as -8 to the n minus 1. You're not allowed to multiply two numbers if one of them has an exponent on it and the other one doesn't. So that negative 2 to the n minus 1 has to stay separate from the 4. It does not equal negative 8 to the n minus 1. Make sure you remember that. So that's what's good about this formula. If you know r and you know a1, just put the numbers in the right place, put a box around it, you got your formula. You're done.